Hi there, we're going to continue our work on solving trig equations today. I did a few examples and talked through a few sort of common errors in the last lesson about how to avoid missing solutions out. So we talked about everything having a second solution 0 to 360, almost everything, forgetting to do plus or minus when you square root, cancelling common trig factors, and we'll also talk today in particular about what happens when we're looking at sine, cos and tan of a function of x, function of theta, and how we change that. So we'll start off with this one first. Cos squared x is a quarter, x lies between 0 and 360. So the first thing I'm going to do is square root it. And because I'm square rooting it, I'm going to remember to do plus minus a half. So cos x equals a half, sine 30, cos 60, x equals 60 degrees, and my second solution, the outer 360, so it's 300. Cos x is minus a half, and then I press my buttons. We're going to end up with, I think it's 120 myself. X is 120 and 240. Yeah, again, the outer to 360, so I've got my four answers there. Remember, so I've square rooted, so I've got plus and minus, and each one leads to two solutions in the 0 to 360 range. Similarly, I've got a quadratic. Quadratics potentially lead to two solutions for sine theta, and each one should give me two answers in 0 to 360. So I've potentially got four solutions. There's a but, we might see it here. I'm hoping to show us numbers here that factorise, so I'm going to try 2 sine theta and sine theta. The only way I'm going to get minus 2 is if I've got a 2 and a 1. The 2 can't go there, or else it would all be even, so the 2 must go here and the 1 must go there. How do we get plus 3? Because that's plus 4 and minus 1 is that. So sine theta must equal a half, or sine theta must equal minus 2. And that one can't happen, so I say no solutions. Sine theta to half, then theta is 30 degrees, and the second one for sine, because it's inverse sine of a plus, you add to 180, so it's 150 degrees there. Think about your rough sketch here. 0 to 180, there's 30, there's a half, there's 30, and there's 30 back from 180 to 150. Okay, so in that case there, I thought I might have four solutions. I only got two, because only one of them led to solution for sine. A couple more examples here, similar sort of thing. Quadratic, no constant, so I've got a common trig factor. I can cancel it, but I must remember that tan theta's naught is a solution set. The better way to actually show it is to factorise it, tan x rather than tan theta, sorry. So I've got tan x in the brackets plus 1 equals 0, so either tan x equals naught, so x is naught, 180, 360, or 540, up to and including 540, so four solutions there, and tan x is minus 1, as my x is, my calculator will tell me it's minus 45, tan repeats every 180, so I add 180 to get 135, 315, and add another 180 under that to get 495, and that's still in my range. So all in all, 7 solutions. Be aware if you just use your calculator and cancel your trig common factor, you wouldn't have got those four. Your calculator only tells you minus 45, not even in the range, sorry. Example 7 then. This is the first time we've got a transformation. Sine of x plus 30, because it's in the brackets, it would take the ordinary sine curve and shove it 30 degrees that way. How I end up solving it, I'm going to do the inverse sine of 0.2 to get whatever it does, and I'm going to undo the function at some stage or other to get what the x answer is. I'm expecting two answers in 0 to 360. What I must do, what I think is a handy thing to do, is to rewrite the function. I've got it theta there, I've got x there, so it should be x's between that and that, as x plus 30. And if x plus 30, well, when x is 0, x plus 30 is 30, and that will be 390. So I get the calculator, I do the inverse sine of 0.2, get my arm in there, calculator, check I've got it in degrees, you can just about see it, shift, sine 0.2 equals, apparently, I haven't, I'll try again, wrong mode, so put it in degrees, shift sine 0.2 equals 11.53 degrees, so 11.5 degrees, okay, that's not in this range. I haven't even got one answer. Notice that I like doing this bracketed thing to remind myself that my calculated answer isn't even in the range that I need. Now, remember, everything repeats every 360. So what I can do with it is add 360 onto it to get 371.5, because that's in my range. My other one, because it's the inverse sine of a plus, these two values here will add up to 180. So if I do 180 minus my 11.5, I get, whatever that is, 168.5. Okay, those two values satisfy this equation, so that the sine of it is 0.2. What I now do is undo the function. That's the very last thing to do. So I'm going to take 30 off each one of these, get 138.5 and 341.5, and they match up with x being between 0 and 360. So I'll say it again. Extend your range based on the function in the bracket. Use your calculator. Find your second solution in 0 to 360. In this case, the calculator answer isn't even in the range, so everything repeats every 360. So keep adding 360s on as appropriate, or taking 360s off depending on what the range is, until you get all your answers in the given range. Another couple of functions here. Cos 3x. What the 3 does, if you remember, because what it should actually be is that it's cos bracket. When you press sine, cos or tan in your calculator, it'll put a bracket there straight away. And because it's a function within the bracket, it changes it this way. Well, to be honest, because it's 3x, it will actually change it that way. It will squish it by a factor of 3, so it will be a stretch of a scale factor of 1/3. So I get 3 times as many cos curves, cos waves in the 0 to 360. Instead of having one full cycle, I'm going to get 3 of them. What it means is, instead of having 2 solutions in 0 to 360, I'm going to get 6 solutions. Okay, yet again, I'm going to take my range for x and rewrite it. So times the ends by 3 to get 0, and 3 lots of 360 is 1080. And then do the inverse cos of root 3 over 2. Sine 30 is cos 60, is a half, and cos 30 is sine 60 root 3 over 2, so it's 30 degrees there. And then get my second answer, cos, the add up to 360, so 330. And then, because I can go all the way up to 1080, keep adding 360s onto it. So that one will be 390. And this one, 360 onto that one, is going to be 690. Add 360 on again, I'm going to get 750. Add 360 onto that one, I'm getting 1050, and that's just about in the range. And I've got, hey presto, 1, 2, 3, 4, 5, 6, and then undo the function. Divided by 3 to get x is 10, 110, 130, 230, 250, and 350. That's all my values for x in that range there. So as I say, what happened is I ended up with cos curve like this, 1, 2, 3 in the 0 to 360. So at that point there will be at 120, that one there at 240, and that one there at 360. So if I go across at root 3 over 2, I've got this answer here, 2, 3, 4, 5, and then 6. So hopefully you can see it's going to be 10 degrees there, 10 degrees back from 120, ahead of 120, 10 degrees shy of 240, and that way of 240, and so on. Each one of these, 1, 2, 3, 4, is going to be 30, 60, 90, and so on. So you can hopefully see why I've got the answers that I've got there. Okay. Last one. Tan 1, tan 2x plus 65 is 1. Yet again, take the function, double it, and add 65. So 720 add 65, 785 degrees. Do the inverse tan of 2x plus 65 and get all my answers in the given range. So the first one, 45 degrees. That's not even in the range. So I'll bracket it to remind myself, because I'm expecting not just 2 answers, but because of the 2x squished it by a factor of 2, I'm expecting 4 answers. So tan repeats every 180, so keep adding 180s onto it, 225. Keep adding 180 onto that one, 405. 180 into that one, 585, and then 765. And then take 65 of all of those and halve it. So x is 160 over 2, 80. 400, 340 over 2, 170, and so on. And these should go up every 90 now. So it should be 260 and then 350. Okay. Take 65 of that as a check, 520 and halve it. Take 65 of that, 700 and halve it, 350. So remember, the key thing is with these sin, cos, tan of a function, rewrite the range of the function. Do your calculating to get the first answer. If it's not in the range, you still use it to generate the second one in the 0 to 360, but then keep adding on 360s as appropriate to get all these, and the last thing you do is undo your function. So hopefully that's giving you a good insight into the sort of mistakes people make in solving your Year 12 trig equations.